Assalamualaikum and good day, Madam Rohaiza and fellow students. We are from Group 12 and today we will be presenting our project on bamboo biomass power generation. When discussing renewable energy, most people immediately think about solar panel and turbines. However, another promising renewable energy source such as biomass, particularly bamboo biomass. In this presentation, we will explain on how bamboo waste can be converted into electricity and discuss the environmental impact associated with this system, both positive and negative. Before we begin, let me briefly introduce my group members. First, we got Nazira binti Azrul Nizam. Next is Syukrina Adiba binti Nur Asman. And finally, my name is Putri Nur Alabalkis binti Fikriawan. Throughout this presentation, each member will explain different aspects of the bamboo biomass power generation system.
Having understood the generation process, we will now focus on the environmental impact of bamboo biomass power generation. Environmental impact can generally be divided into two categories, positive impact and negative impact. Understanding both aspects is important because every energy system, including renewable energy system, has advantage and limitation. We will begin by examining the positive environmental impact function. One major environmental benefit of bamboo biomass is effective waste utilization. Furniture manufacturing activities generate a large amount of bamboo residue. If these residue are discarded, they can occupy landfill space or contribute to environmental pollution. By converting this material into fuel, waste become available resource instead of an environmental burden. Another significant advantage is renewability. Unlike fossil fuel, which exists in limited quantities, bamboo can continuously grow and harvest. Its rapid growth rate allows a sustainable fuel supply to be maintained without exhausting natural resources. As a result, bamboo biomass support long-term energy security while reducing environmental pressure associated with waste disposal. Another positive impact is the reduction of agriculture and industrial waste disposal problem. Instead of allow waste material to accumulate, they are converted into useful energy. This supports the concept of a circular economy, where resources are continuously reused rather than discarded. Additionally, bamboo biomass generally produce a lower net carbon footprint compared to fossil fuel. During its growth, bamboo absorbs carbon dioxide from the atmosphere through the photosynthesis. Although carbon dioxide is released during combustion, part of this emission is offset by the carbon previously absorbed during growth. Therefore, the overall environmental impact is significantly lower than the conventional fossil fuel-based electricity generation. Bamboo also plays an important role in environmental conservation. Its extensive root system helps stabilize soil, reducing erosion and maintaining land quality. This is especially beneficial in areas that experience frequent rainfall or are vulnerable to soil degradation. In addition, bamboo biomass supports sustainable resource management. By utilizing renewable resources and converting waste into energy, the system minimizes resource wastage while promoting long-term environmental sustainability. Ultimately, bamboo biomass contribute to both ecological protection and responsible resource utilization.
Next, I will explain about negative environmental impacts. Although bamboo biomass offers many environmental benefits, it is important to acknowledge that no energy system is entirely free from environmental impacts. Like other combustion-based technologies, bamboo biomass also presents several challenges that must be managed properly. Understanding these challenges allows engineers to design more efficient and environmentally responsible systems. One of the primary concerns is air emission produced during combustion. When bamboo is burned, gas such as carbon dioxide, carbon monoxide, nitrogen oxide, and particulate matter are released into the atmosphere. If emission levels are not properly controlled, they may contribute to air pollution and environmental degradation. Another issue is ash production. Following combustion, ash remains inside the system. Over time, this deposit can accumulate on boiler surface and heat exchanger components, reducing heat transfer efficiency and increasing maintenance requirement. Therefore, proper ash management is essential to maintain system performance. Technical challenge is slagging. Bamboo naturally contains minerals such as potassium and sodium. At high combustion temperatures, these minerals can melt and form sticky deposits known as slag. This deposit can accumulate inside the boiler, restricting airflow and reducing combustion efficiency. If left untreated, slagging can increase maintenance costs and shorten equipment lifespan. Additionally, because biomass combustion generates emission and ash, proper emission control equipment and routine maintenance programs are necessary to ensure environmentally responsible operation. Fortunately, several mitigation measures can significantly reduce these environmental impacts. The first measure is installing flue gas filter. This filter capture fine particulate matter before it is released into the atmosphere, helping improve air quality. The second measure is controlled combustion. By carefully controlling combustion temperature and air supply, emissions such as carbon monoxide and nitrogen oxide can be reduced. Another important strategy is sustainable bamboo replanting. Continuous replanting ensures that harvest bamboo is replaced, helping maintain carbon neutrality and long-term sustainability. Finally, ash recycling can be implemented. Instead of disposing of ash as waste, it can be reused as a soil amendment, reducing waste generation while improving soil quality. To better understand the significance of bamboo biomass, it is useful to compare it with fossil fuels. Unlike fossil fuel, bamboo biomass is renewable and can be replenished continuously through cultivation and harvesting. Bamboo biomass also utilize waste material, whereas fossil fuel systems rely on the extraction of non-renewable resources such as coal, oil, and natural gas. From an environmental perspective, bamboo biomass generally produces a lower net carbon footprint because of its carbon absorption during growth. Economically, it supports local communities by creating opportunities in cultivation, processing, and energy production. Overall, bamboo biomass represents a cleaner, more sustainable, and environmentally responsible alternative to conventional fossil fuel energy systems. Next, how bamboo biomass contribute to environmental sustainability by reducing waste and producing renewable energy. First, bamboo biomass help reduce agricultural waste disposal problems. Instead of burning or dumping bamboo residues, the waste can be collected and used as a valuable energy source. Second, through the combustion process, bamboo biomass is converted into thermal energy. This heat is then used to generate electricity, making bamboo a renewable alternative to fossil fuels. Lastly, bamboo waste has a relatively high heating value around 50 to 20 megajoules per kilogram. This means it can produce a significant amount of energy when burned, making it an efficient biomass fuel. Overall, bamboo biomass not only reduces waste accumulation but also transforms waste into useful and sustainable energy. This table compares conventional power generation with bamboo biomass power generation. Conventional power generation relies on non-renewable resources and produces high carbon emission and air pollution. It also does not utilize agricultural waste effectively. On the other hand, bamboo biomass uses renewable resources, produces lower emission, and converts bamboo waste into useful energy. Because bamboo grows quickly, can be replanted. It offers higher resources sustainability and a lower overall environmental impact. Therefore, bamboo biomass is a cleaner and more sustainable alternative to conventional power generation. In conclusion, bamboo biomass has significant potential as a renewable energy source. It converts waste material into useful electrical energy while reducing dependence on fossil fuel. The system provides numerous environmental benefits, including waste reduction, lower carbon emission, soil protection, and sustainable resource management. Although certain challenges such as emission, ash production, and slagging exist, these impacts can be effectively controlled, appropriate engineering solution, and sustainable management practice. Therefore, bamboo biomass power generation offers a practical and environmentally responsible solution for future energy needs.